Hi, and welcome to the video on general formula of polynomials. Now, before we begin taking notes, I kind of want to remind us about where we are in our lesson. So going back to our map, what you may recall is the last time we were together, we worked on building the road from data table to classification by degree. So now we know how to classify polynomial formulas from their data tables using successive differences. And so this road is now open to us, but there are still several roads that are closed, and we're going to focus on this road here, the road between data table and formula equation. So what we're wanting to learn next is how to write the formula equation when given the data table. But before we do that, we have to know a little bit about the general formulas of polynomials. So all polynomials have a general formula. We're going to look at some examples so you get a sense of what I mean. Now, when you hear linear, you may be thinking of y equals mx plus b, and you're absolutely right. The equation for a linear function is y equals mx plus b. But in order to be consistent with the other general formulas of polynomials, we're going to use this as the general formula for a linear function. F of x equals ax plus b, where a is the coefficient in front of x and b is the constant at the end. Looking at our example underneath our general formula, we see that a is 3 and b, the constant, is 7. Let's look at a quadratic. The general formula here is f of x equals ax squared plus bx plus c. And here the coefficient a is 5 in our example, b is negative 7, you cannot forget the sign, and that is the coefficient in front of x, and c is 9. Finally, we have a cubic. I bet you can guess now what the general formula of a cubic will look like. Well, it looks something like this. F of x equals ax cubed plus bx squared plus dx plus d. Look at our example here. If we look at our example, there's no number written in for the coefficient in front of x cubed, which is our value of a. And we know that when there's no number written in for a coefficient, that the coefficient is 1. So a in this case is 1. It's easy to see that b is 7, but there's a missing term here for the cx. We'll come back to that. And it's also easy to see that d is 12. Okay, so now what's up with that missing term? Well, it's important to remember that coefficients and variables are being multiplied together. So if your coefficient is 0, then that term that has that coefficient in front of it is going to disappear, right? Because 0 multiplied by anything is always 0. So it turns out here that c is actually 0. All right. Now what does that have to do with us writing the formula equation from a data table? How are we going to build that road with that information? Well, you'll learn most of that in class, but it's important to know that in order to write the formula or equation from a data table, you must be able to find from the data table the values of the coefficients, a, b, c, d, etc. All right, so now let's get some practice in writing these general formulas. And this is where your notes begin, so I need you now to have out your composition book. And in your composition book on the left-hand corner, you're going to write the date. On the right-hand corner, you're going to write the page number, and at the very top, you're going to write writing the general formula of a polynomial equations. Okay, after you've written that down, and again, feel free to pause when necessary, you're going to list the steps. So underneath steps, the first step is to write f of x. The second step is to use the classification to identify the highest exponent or power. The third step is to write the first term, ax to the highest power. And the fourth step is to keep going with coefficients in alphabetical order and terms in standard form until you get to the constant. And each of your terms are going to be separated by a plus sign. Okay, so let's look at this with a real example here. So for example 1, if you're asked to write the general formula for a cubic function, the first thing you're going to do is you're going to write f of x equals. And this is just to remind you that you're writing an equation because remember, equations have an equal sign with something on either side. So f of x is on the left side of the equal sign. That means we need to fill in this space on the right side. And that leads us to our second step, which is we're going to use the classification to identify the highest exponent or power. Well, I know it's a cubic function, so this is where I got to do some thinking, right? Cubic function is third degree, and the degree is equal to the power, the highest power. So I know that the highest power here is going to be 3. So my first term leading into the third step, which is writing the first term, is going to be a, the coefficient, x to the third power. So ax cubed is what I got here. Now I'm going to keep going with all my coefficients in alphabetical order and terms in standard form. And when I say terms in standard form, all of the exponents are going to keep decreasing by 1. All right, so if the coefficients are going in alphabetical order, the next letter in the alphabet is B, so my next term better begin with a B. And the power, the next power I should see should be second power because that's 1 less than 3. So I'm going to get bx squared as my next term. Okay, I bet you now can guess what the third term is going to be. Well, if I've written a b here, my next term should have the coefficient of c. And the exponent should be 1 less than 2, which is just 1, right? So remember that when the exponent is 1, we don't write it. So we now have this next term here, cx, so our third term is cx. Are we done? No, we're not done, because the one thing we can't forget is to keep going until we get to the constant. So once you get to the term that has an exponent of 1, the next term you're going to write is going to be the constant. We always end with a constant, and our constant here in this case is d. Don't forget your constant. All right, let's look at one more example together. And this one is example 2. It's a 6th degree polynomial. So looking at this example, we see that the first thing we need to do is we need to write f of x. So let's go ahead and write that. F of x equals. And that's just a reminder again that I'm writing an equation. And then we're going to use the classification to identify the highest exponent or power. So if I have a 6th degree, I know that the power is going to be 6 because the degree is 6, so the highest power must be 6. So my first term is going to be ax to the 6th power. So go ahead and write that in. Now I'm going to keep going again with my coefficients in alphabetical order and terms in standard form, right? So next term is going to begin with a b, and that's going to be bx to the 5th because 5 is 1 less than 6. So I'm going to add bx to the 5th. And again, I'm going to keep going. So the next term is going to begin with a c, and the power is going to be 4. And that gives me cx to the 4th power. Then we have dx to the 3rd, ex squared, and fx. Notice this is not f of x. The coefficient is f, and our exponent is x. This is not the same thing as this. F of x, remember, is our y. This is just saying the coefficient f multiplied by the variable x. Okay, are we done? No, of course we're not done, because remember we always have to end with a constant. And so my constant here using the alphabet is going to be g. Now, what's a quick way that we can use to remember to add the constant, or a quick way we can use to just check that we did it correctly and we didn't skip any terms along the way? We can check the number of terms. And they should equal the degree plus 1. So for example, here's the 6th degree polynomial. So I should have 7 terms. I have 1, 2, 3, 4, 5, 6, 7. And that's because the number of terms we have, maximum number of terms we have, needs to equal the degree plus 1. So next to steps at the very top, I want you to write a star and check that the number of terms equals degree plus 1. This is a really good check, and it just helps you to keep track. Okay, moving on. And not forgetting our constant. You're going to now work on some practice. So the next part of in your notebook, you should have space either below it to do practice problems. And in these practice problems, you're going to write the general formula for the following polynomials using this example. So where we have a cubic function, I just write next to it the general formula, f of x equals ax cubed plus bx squared plus cx plus d. You're going to do that for quadratic, quartic, 5th degree, and 7th degree. And then we're going to come back together for the next practice. All right, so the next practice here we have, you're going to identify and correct the mistakes in the general formulas. So for example here, we have a cubic function, and clearly there's a mistake here. Well, let's see if we can figure out the mistake using our check. If it's cubic and it's third degree, how many terms should we have? 3 plus 1 gives us 4. We should have 4 terms. I see 3 terms here, so that tells me I'm missing a term. All right, so I need to figure out what that missing term is, and I'm going to do that by using the knowledge and the notes that we have. So the first term begins with a, it's good for a coefficient, and the power is 3, which makes sense because the highest power should be 3 for cubic. Now I go to my next term, I see that the coefficient is b, that looks good, but my highest power here should be a 2 because it should be 1 less than 3, so that should be bx squared. That's a mistake. So that's the mistake there. So what I'm going to do is I'm going to write missing second term, and then I'm just going to correct it, because notice it was the second term that was missing. You're going to do that for the rest of these 4 examples. And then when you're done, there's one more practice set for you. Okay, the last thing I'm doing in practice, and this is really going to lead us up to our lesson next time we get together, which is you're going to fill in the data tables by plugging x into the general formula. Well, I'm going to go through an example with you so you see what I mean. In this example, we're dealing with a quadratic formula, and we have a data table that's partially set up. So you always want to have 2 columns, x, and then here your f of x. And instead of just writing f of x, I also want you to write the general formula for the function that you're looking at. So this says f of x equals ax squared plus bx plus c, because that's the general formula for a quadratic. And I listed these numbers in for my x, 0, 1, 2, and 3. What I need to do is find out what the values of f of x are going to be by plugging in 0, 1, 2, and 3 for x into this general formula. And I'm going to do the scratch work on the side, so we're going to do the first one together. X is 0, so I'm going to plug in 0 for x, and I get f of 0 is equal a times 0 squared plus b times 0 plus c. I know that 0 squared is 0, so f of 0 is going to be a times 0 plus b times 0 plus c. Now a times 0 and b times 0, those are both zeros, and when you combine zeros together, it gives you zeros. So all of this is just 0. So I have 0 plus c, and my final answer is c, so I'm going to put that in here. Now I'm going to try f of 1, so I'm going to substitute 1 in for x into the general formula, and I'm going to have a times 1 squared plus b times 1 plus c. Well, 1 squared is just 1, right? So f of 1 is going to equal a times 1 plus b times 1 plus c. And a times 1 is a, and b times 1 is b, and then we have c here. So this whole thing here just equals a plus b plus c, which I'm going to write down in this space here. Okay, f of 2. I go ahead and do the same thing there, and when I do that, I get a times 2 squared plus b times 2 plus c. Now 2 squared is 4, so what this gives me is a times 4, b times 2 plus c. Now what we notice here is that the number is written after the letter. Typically when we write things like this is we like to write the number first before the letter. Now you may be thinking, wait a minute, a, b, and c are coefficients. That's true, they are coefficients, but because they're unknown, we're kind of treating them like a variable when we're solving for them, right? So when I go rewrite that into the table, I'm going to write the number first. So instead of writing A4, I'm going to write 4A, just because my eye is used to reading it that way. And the same thing with B. I'm going to write 2B, and then I'm going to add C. And then last but not least, we do, where x is 3, we get a times 3 squared plus b times 3 plus c. That gives us a times 9 plus b times 3 plus c. And I am going to rewrite it again as, with the numbers in front, 9a plus 3b plus c. You're going to do that for the following functions. You're going to do it for linear and for cubic. And your tables need to look like this, where you have, again, these numbers for x, 0, 1, 2, and 3, f of x, and the general formula written in the second column. And you'll do your work on the side just as I've done. All right, so the next time we get back together, we're going to work on building that road using the knowledge that you just gained. I hope this video was helpful, and have a quality weekend.